solutions here on the worksheet today. And just remember, like yesterday, if you get to the answer a different way than I do, that's completely fine. Just make sure that it matches what I get. Unless, of course, I make a mistake, and I would like you to let me know if I do make one, so please do. All right, let's jump in here. Look at number one. Looking at combining a bunch of different exponent laws on this worksheet, but the first one is all multiplication. So there's basically two methods you can look at. Either move the negative exponent things to where they're happy first and then start doing some stuff, or just multiply straight through. And that's what I'm going to do. And I'm going to reorder this. Commutative property says I can do this. Because remember, like we talked about, 2 times 3 equals 6, just like 3 times 2 equals 6. It doesn't matter how we multiply those two numbers together, 4 or 5 or 6 or whatever, as long as they're all being multiplied, we can mess with the order in which we do that. This doesn't really apply here, but remember, constants have their own power. So 2 is to the first. 2 is not being multiplied by any other constant, so we're left with 2. When we have the same base, like a and a, the shortcut says I can add those exponents together. So a to the 5th, and same with my 2b terms. 2 plus negative 1 is 1, or just b. So our final answer here is 2a to the 5th times b. And we can leave that one just like that. Okay. Number 3. Like I showed you yesterday, you can think about this one in the long version. It's really telling us we're going to take the inside quantity and multiply it together 3 times. So we would say negative 3m to the 4th, n to the 2nd, and multiply that 3 times. Okay. So one thing that jumps out at me right away, and we don't have to do it the long way there. You can. It's just going to take you a little bit more time. That's completely fine. But one thing that jumps out at me is I do have a negative here, and it's to the 3rd power. That tells me, since the power is odd, that my overall answer is going to be negative. Another way that you can do that is look at it as negative 3 to the this to the 1st power, and a power to a power says I can multiply these all together. So 3 times 1 gives me 3. 3 times 4 gives me 12, and then 3 times negative 2 gives me negative 6. We can go up that way. It's kind of strange sometimes for students to look at it this way. So if you just realize, okay, odd power, negative, that means I'm going to get a negative answer. That's completely fine. Just do it that way. And just know you're going to have a negative. But anyway, 3 to the 3rd power is 27. And yes, that is negative. M to the 12th stays. It's happy. Remember, everything is over 1 at this point. However, n to the 6th is not happy. That wants to move down. N to the negative 6, sorry, is not happy. And it becomes positive once it moves to the basement. So in the denominator there. All right. So again, not the only way to do that one, but that works. Number 5, easiest problem on here. The entire quantity is to the 0 power. Anything to the 0 power is 1. So there we go. That's number 5. Looking at number 7. This one doesn't have much to do either. When you see things to the 0 power within your fraction or problem or whatever multiplication, whatever you're working on, you can cross it out because really, since y to the 0 power is 1, you really have 3 times 1 on the bottom there, which means it's just 3. And if we look further, there's really nothing else here that can cancel out or group together so that top stays the same. There we go. So yeah, 2 over 3, can't reduce that. X to the 4th doesn't have anything else that goes with it, neither does y to the 3rd. So that's all we can do for 7. Number 9. Let's look at well, first, I guess 0 powers, let's take care of those. We have a b to the 0, which is just 1. So anything times 1 is just itself, so the bottom stays the same. Let's look at what's happy and what's not happy and move those things where they want to go. One thing you're going to want to notice here is this negative a. It's not, the negative is not in parentheses with that a. So that negative 2 doesn't apply to the negative on the outside of the a there. If I rewrote this, I could write it like this. Negative 1 times a to the negative 2. There's secretly a 1 right there. And negative 1 has its own power. It's to the first. So if that helps you kind of understand the negative part, that's good. Keep that in mind. All this really means is we're going to have a negative answer. So, all right, and then we've got some things that need to move. A to the negative second wants to go upstairs. B to the negative third wants to move downstairs. So we've got 4, 8 to the now positive second over. I moved my negative out front, so really I've got just B to the third on the bottom. And we can leave it just like that. Now you can leave the negative on the bottom and the denominator, move it to the top if you want to. Just know that we have a negative quantity. Okay, number 11, the most interesting one on here. Yesterday we talked about how to handle something like this. First thing I'm going to do is look at my zero power. Anything that I can do to simplify it first can be helpful. So sometimes people find it more beneficial to work from the inside out and go that direction. So the bottom, we can make that very simple because it's this entire thing is to the zero power, which means the bottom is 1. I like that. I like when we can cancel some stuff out there. So that's good. And if you want to work from the inside out, one thing I would do here then is take my 4, and we've got power to a power rules going on here. And note, we have a negative that's included, okay? So it's to an even power. That means that negative is going to disappear. That would be like taking this entire thing, multiplying it out 4 times, and that's why the negative will disappear. So just leave it out when you do this, so just like I'll do here. So I'm going to go 4 times 4, so h to the 16th power, and 4 times negative 3, which is negative 12. Okay. And then you've got a couple options at this point. You can immediately distribute the negative 2 to both the other 2 terms. That would look like this. Power to a power, so then I would have h to the negative 32 power, and k to the negative 2 times negative 12, that is to the 24th power, and you would find out that this wants to move downstairs. So our final answer is k to the 24th over h to the 32nd. And you can do it that way. Just as a quick reminder, if you didn't want to do that part, some of us liked this little shortcut yesterday. Whenever your entire quantity is to a negative power, you can flip the entire thing. And now it is to the positive second. You're going to find out that we come out to the same answer no matter what we do there. So, and then you can distribute again, 1 to the 1 or 1. 1's just going to be 1 no matter what. That's 1 to the second power. Just 1. Distribute, h to the 32, k to the negative 24th over 1. This wants to move up. Okay, another round. You could have moved things around in here before you did anything. Just all sorts of options. So whatever you want to do, probably just confuse a couple of you. Just do what works for you. And if you got that answer, awesome. So keep doing what you do for that. 11's tricky. So many different options that you have there. 13, I won't get into any of the mess of it. I'll just get to the answer. Anything to the 0, cross off. Those are all 1s. And again, 1 times anything isn't going to do much. Won't do anything at all. So let's look what we got here. That entire quantity is to the negative second power, so I'm going to move that down right away. We have nothing second. However, we do have a negative out here, so our fraction will still be coming out negative. And final answer for that. Okay, let's switch gears, talk about some scientific notation, finish this thing up. Sorry, I'm trying to move as fast as I can, and ended up on the last one, number 11. The one before 13. Giving you probably too many options, so that was my fault, sorry. Okay. Alright, number 15, scientific notation. You're multiplying everything together. They want the answer in scientific notation. Commutative property says I can reorder the multiplication. So let's take our numbers, 1.93 and 3.6, and let's group those together. And then we will also then group together our tens, so 10 to the negatives first and 10 to the 6. And the reason that's nice is because now I can take these have the same base, I can add these exponents together since we're multiplying them. So 10 to the 5th. And then we just gotta see what 1.93 times 3.6 turns into. And I'll grab my calculator here real quick. Save us more time. Alright, 6.948. And if that comes out to correct scientific notation, which it does, you can just go ahead and circle it. Your other option would have been to figure out what those numbers actually were in the beginning, multiply them together, so the two standard form numbers, and then got some big number or whatever, and then converted that to scientific notation. You can always do it that way too, just takes a little bit longer, and I'm all about shortcuts. Alright, 17. Again, we'll do this one even quicker. 2 times 9.7. We get 19.4 when we do that. And then 10 to the 5th times 10 to the negative 4th. I can add those exponents together. So we actually have 10 to the 1st. Alright, so this is not in correct scientific notation. So one of the best things that you can do here, we talked about different ways that you can figure out how to put this into correct scientific notation. Well, let's just turn that number right there into scientific notation. This would be 1.94 times 10 to the 1st power, right? If we move that to where it needs to be. Well, don't forget then that we also have this here times 10 to the 1st power. So really we've got 1.94. 10 and 10, same base. I can add these together. 10 to the 2nd. We talked yesterday about some other options for that too, but that seems to be a real nice one. Gets to the answer every time. Alright, 19 and 21, same concept, but now we're dividing. So I'm going to do 6 divided by 6.7. And this one comes out messy. 0.89552238881, and so forth. So I'm going to round this to 0.896. And now that we are dividing, we have the same base here, I can take these numbers and subtract them. So I got negative 1 minus 2, that's the negative 3rd. Again, we are not in scientific notation, so let's take the beginning number and let's put it into scientific notation. So I would want to move this here, so this would be 8.96 times 10 to the negative 1st. And again, remember that we've got 10 times negative 3rd right here. So we can add these two together now. And we have 8.96 times 10 to the negative 4th. Alright, and lastly, I don't have much time. Actually, I've got like 20 seconds. So, we're just going to leave 21 out before my video cuts me off. Sorry.